The other numerical method you need to know is called the Newton-Raphson Method. And this works by sliding down the tangent to y equals f of x to get closer to the root. So I've got an example here. We're trying to get to this root. So we actually are working with the root this time. And I've got a starting value here of x0. So the way this method works is you go up to the curve. We'll start with the diagram this time. And then you draw in, mathematically draw in, but at the moment we can just draw it in, the tangent to the curve, and you slide down the tangent, and where that crosses the x-axis gives you your next x value. Then you go up to the curve, slide down the tangent, up to the curve, slide down the tangent. Obviously we need to do this mathematically. So we need to find the equation of the tangent. So a point on the curve is here, or a point on the tangent even, and the coordinates there are x0, f of x0, which is what you get when you put x0 into f of x. So I'm going to do y minus y1, which is f of x0, equals the gradient of the tangent, which is the gradient of f of x at x0. So that's your m, x minus x1, in this case it's x0. So that's equation of tangent using that point and the fact that the gradient of the tangent will be the gradient of the curve at x0. And then we also know that when y equals 0, x is equal to x1. So that's the coordinates of this point here on the tangent. So that's x1, 0. So I can substitute those into here. So when y is x1, and this equation will then balance. So we're basically trying to find where this tangent crosses the x-axis. Sorry, that's meant to be my y. My y coordinate is 0. By setting y to 0, we can find where it crosses the x-axis. So f dash x0, x1 minus x0. And I just want to rearrange this now to get x1 on its own. So x1 minus x0 is minus f of x0 over the gradient of x0. I'll try and keep this on one board because it's a bit nicer. And then I can add x0 on. So x1 is the starting value minus f of x0 over f dash x0. So given this one here, you can use this formula to find this one here. And then you could repeat the whole process by going up to the curve and sliding down the tangent, and that would take you to x2. The coordinates here are x1, f of x1. So the next value along will be x1 minus f of x1 over f dash x1, etc. So this leads to the Newton-Raphson iterative formula. Which is that x n plus 1, so the next x value along is the one before it minus f of xn over f dash xn. We will actually have to work these out. We're not just going to plug it into the calculator and press equals this time. But you're basically using your result before plugging it into here to get the next one each time. And that's what an iterative formula does. So I'll, the other thing I was going to say is that is in your formula book. So you don't need to remember it. So they've been quite kind with this. They're actually quite kind in general with the numerical methods questions. I'll do an example on the next video so you can see it working. But yeah, the process just keeps going. So up to the curve, slide down the tangent, and then you can actually hone in on the root quite quickly using this method.